Hello, this is Albert from AWB Electrical and Marine Services, NQ. I'm just going through, this is like a more of a follow-up video from another video I did about refrigerant heat exchangers or liquid suction heat exchangers. So this is actually a low temp freeze system. It's got two Technic plates in it with a reasonably sized compressor in there. And this is actually running on R404, and there's your refrigerant heat exchanger or liquid suction heat exchanger. So this is an example of it in situ. So the liquid line, discharge liquid line from the after the condenser is coming through here, and it goes downwards into this heat exchanger, and then it goes through and it comes out, loops off the bottom there. Comes back through, and then it goes back around through to the solenoid valve, and it goes in through the TX valve, or your metering orifice. In this case, it's TX valve. The suction basically comes up off the bottom there, and it loops around this loop, then it comes up through the bottom, and then it comes out from the top here. So these liquid suction heat exchangers do have a good couple of features with them when you use them. Typically in a low temp system like this, so this is aiming for about -18, -20 inside the box. What normally you'll see is the CPR or this return pipe working here from the compressor back. You just turn a solid block of ice, and then when it defrosts, you get all this basically water and puddling there, and sweating on the pipe work and that. So that is a bit of a bonus. So it means insulation doesn't have to be as critical. Not that it shouldn't be subpar, but yeah, normally these CPRs and all stuff like this, all this pipe work coming back here, you just start freezing up because the return gas is so cold. Because you're taking the cold and you're exchanging it with this, you're also basically putting energy back into the system and you're cooling down the pipe work. So an example of this is on this temp gun. You can see there it's showing about 32.5 degrees on the pipe right in the centre. And then after the liquid suction heat exchanger, on there, it's showing, sorry, focus. Let's get the focus. That's there. Look there, it's showing about 27.7. So it's giving a, so it's reducing the heat between this side and this side about 5 degrees. And then the cool from there coming back is it's basically it's heating this pipe up, but the pressures don't change. So this is not something that basically makes something for nothing. So there is some losses in it, but you're basically feeding it back in. But normally these things, I believe this is actually a good little thing to do, because basically instead of having the sweating and ice build up and so forth, and the fact that it basically improves performance. Can improve performance, in this case it does. They're definitely worth it, and if you go back to my other video to actually manufacture one of these, you can see there's not actually much to them. Like that's similar construction to the one I made. So it's got quarter in. The liquid side's poured through there, and then the suction side is basically just 3/8 pipe in and out to the ends. So as I said, like normally this here will just start freezing up on long use. This thing's been running for about a day, freezing these plates down, and yeah, those like this is ice all over. So it makes it a lot cleaner. So hopefully that's helped someone out. If you don't know where a liquid suction heat exchanger is or a refrigerant heat exchanger, I've got a video of what I made one. Hopefully that makes sense. But the main thing is with them, just the flow is opposite, so the gas goes one way, so the gas is coming back and the liquid's going down, and then it's not open to the side there, it's just exchanging the heat from the coil of the quarter-inch copper inside it. So hopefully that helps.